Welcome everyone, my name is James Waring. Along with me is Elias Batar, Matthew Means, Sean Monagle, and Chris Chang. And we are TheraCord, and we'll be presenting you today the venture that we've been working on for the past year. First, I'd like to thank each and every one of you for coming out this morning and taking the time to listen to our presentation. Leukemia, stroke, Alzheimer's, and many other life-threatening diseases. What do they all have in common? Well, the over 300 million people worldwide affected by these diseases could potentially be treated using stem cell therapies. Now, there's a variety of sources of stem cells. However, umbilical cord blood has presented itself as the most viable source of these cells moving forward. Yet today, there's a problem. The current methods to collect these cells are simply insufficient, failing up to 60% of the time. We are TheraCord, a medical device company that's solving this problem with the CBX system, an innovative new device that optimizes the collection of umbilical cord blood stem cells. By doing so, this will lead to better clinical outcomes for transplant patients, and this even expands the use of cord blood to adult patients in adult therapies. This will also enable the realization of these stem cell therapies for over 300 million people worldwide. And finally, this is a rapidly growing market. Currently valued at $500 million, it's expected to more than triple to $1.8 billion by the year 2020. But let's take a step back and talk about where do we get these cells. Well, cord blood stem cells are found in the fetal system, which is comprised of the child, the umbilical cord, and the placenta. Now, after the child is delivered during live birth, the umbilical cord is clamped, then cut, then delivered. Now, remaining in the vasculature of this tissue is umbilical cord blood, and this cord blood is actually the richest source of stem cells of any tissue found within the body. And in addition, there's no ethical considerations as compared to embryonic stem cells, and they even have strong government legislation supporting their adoption. But as I said before, the current methods to collect these cells are simply insufficient. And this is all because the current technology is a conventional blood bag, much like you would see if you donated blood at the Red Cross. Here you can see some images from the current process, but what you'll notice is it's time-consuming and manually intensive and ultimately relies on gravity alone to drive the collection process. What this means is that up to 60% of the time, the minimum threshold for stem cell banking is not met. In other words, the cord blood units collected today do not have enough stem cells in them to be clinically relevant and are thus thrown away. Now, to make matters worse, even the 40% of the time when these units do meet the minimum threshold, they still don't meet the threshold for adult therapy, and thereby are limited to pediatric cases only. As Dr. Barker at the Sloan Kettering Cancer Center said, even adults and larger children still remain without a suitable graft for transplantation today. So this brings us to our need, the need to maximize the collection of umbilical cord blood stem cells. And this need has been validated by several prominent thought leaders in the industry, such as Dr. Broxmeyer at the Walter Oncology Center, who said there's a great need for high quality and high cell number cord blood units, or Dr. Zambides here at Johns Hopkins, who said there's a great need for high-quality stem cells from cord blood, both for transplantation as well as for future applications in regenerative medicine. So let me turn over the controls to Matt, who will tell you a little bit about our solution.
Thank you, James. Now that we've identified the clinical need, let's go over our design goals. Now, we were designing for two key stakeholders. First, the cord blood bank, which represents our customer. For them, it was imperative that we increase cell yield, and we believed that we could meet this minimum cell threshold for banking at least 90% of the time, while also maintaining the industry standards in cell viability as well as low contamination rates, keeping in mind that our cord blood units would eventually be transplanted to patients for clinical use. On the other end of the spectrum, we were designing for the hospital, which represents the user of our device, where the collection takes place. Designing for the hospital was all about ease of use. So already you can see we were facing a design challenge between balancing ease of use with the different mechanisms we would use to increase cell yield. Walking through the highlights of our design iterations, it began by identifying the fact that people have been experimentally using active mechanisms such as perfusion to drive stem cell collection. So early iterations took the form of a syringe pump. We made this device easy to use by iterating it in a handheld form and making it fully disposable, and we kept this fully disposable mindset for several of the coming months, until December, when our design took a drastic turn. And this occurred during our visit to the Carolinas Cord Blood Bank, a premier leader in the banking industry. Here, we observed a cord blood technician collecting the umbilical cord blood in a fully dedicated space at the hospital. This sent one clear message, that collection could take place in a durable equipment model where we used active mechanisms such as an air bladder for compression and a peristaltic pump to drive suction and perfusion to increase stem cell yield. The other component of our two-piece model consists of a disposable kit shown here as a disposable blue tray. So from here, we filed a provisional patent in February and moved forward with the design of our device until we got to our current iteration, the CBX system and disposable single-use kit. Now, the CBX system is comprised of active mechanisms including suction, perfusion, and compression, all in an automated, easy-to-use form that is set and forget for the end user. It also includes a disposable single-use kit used with every collection that features our novel sterile access technique. And now let me walk you through the process of how it works. First, after the umbilical cord and placenta are delivered, it is placed in the disposable single-use kit, and our novel sterile access technique is used to interface with the placenta. Then, this entire single-use kit is placed within our device, and the automated protocols take over to drive increased collection. Zeroing in here, we have one of our cornerstone technologies in perfusion. Now, we envision perfusion to be used to extract cells from the blood vessel wall in an effort to boost collection, and it's been shown in the literature to boost collection 2 to 5 times more than the existing methods. This brings us to our testing summary. Now, we've tested numerous placentas, and some notable highlights include 5 tested for perfusion. And we've already seen cellular yield increases of 45%. Now, this is using a simple saline plus anticoagulant baseline perfusate. And we envision that we can iterate on this perfusate in the future to optimize the process using other novel factors. Thus far, we've used total nucleated count to measure performance of our active mechanisms, and we'll be using flow cytometry in the future to characterize the specific CD34 positive stem cells used for transplantation. Now I'm going to turn it over to Elias to take us through the business model.
Thank you, Matt. So, in this industry, cord blood banks collect, process, and store cord blood units, and they will be our customer. They generate revenue in one of 2 ways, either through the private model, in which the mother chooses to store the cord blood unit for her own personal use, in which she pays $2,000 upfront fee and annual fee for the next 18 years. The other model is the public model, in which she donates her cord blood unit at no cost to herself, and then the cord blood bank releases that unit to a transplant center for unrelated patients at a cost of $30,000 per cord blood unit. That's where TheraCord comes in. Literature has shown without a doubt that higher stem cell counts lead to better clinical outcomes, and thus we give our customer a competitive advantage. Not only that, we expand the utility of cord blood to adult therapies, immediately expanding the market for our customer as well. Now, cord blood banks will pay us for the device, and we'll generate revenue through a razor blade business model. We plan to sell the single-use kits at $150 a piece, while charging the cord blood banks little to no cost for the CBX system, which we will install in their affiliated hospital. Now, you may be wondering, what's in it for the hospital? Well, the hospitals have established partnerships with cord blood banks, a partnership we'll be able to leverage to enter the market. Now, with the CBX system, the hospital can consistently provide cord blood banks with high-quality cord blood units that are compatible with their current processing and storage steps. These units would then be released for future therapeutic or research use. Now, the market for cord blood is rapidly growing. It's experienced a 13% annual growth rate over the past 6 years. In 2010, 680,000 collections were performed in the U.S., and cord blood banks generated revenue of about $500 million. In 2020, it's projected that 2.4 million collections will occur, and cord blood banks will generate revenue of $1.8 billion. Let me remind you that that projection is based on cord blood being used for pediatric patients only. We immediately expand the market for cord blood, thus shattering these market expectations. Now, what's the reason for this double-digit market growth? Number one is government legislation. 22 states, encompassing 66% of all births, have enacted legislation that require the obstetrician to educate the expecting mother about cord blood collection and cord blood donation. This is greatly increasing awareness. But that's not all. There are currently 180 clinical trials being conducted that use cord blood that could potentially treat over 300 million people worldwide. And many of these therapies are currently in phase 2 and 3 clinical trials. Looking at the risk to enter this market, since we're a medical device, we'll be regulated by the FDA, and since we're dealing with blood, we'll be regulated by the Center of Biologics Evaluation and Research. We anticipate to follow a 510K pathway to market, being classified as a Class 2 device, using the PAL blood bag as our predicate device because we have the same intended use. This will require only safety and efficacy testing to get to market. We've already had informal discussions with the FDA to discuss our regulatory pathway. We are currently in talks with BD about a possible partnership to help us through our regulatory pathway, and have been advised by prominent regulatory law firm Hogan & Vels. From an intellectual property standpoint, We've already filed a provisional patent with the Johns Hopkins Technology Transfer Office and will be looking to file a full utility patent by the end of the year. We believe we have several patentable claims, including the novel perfusate, its composition and its use, as well as the method to access the vasculature in a sterile manner, as well as other non-obvious mechanisms to increase the cell yield. Now, the market for cord blood is an international market. There are 200 cord blood banks worldwide. 67 banks operate within the United States, and they have relationships with 180 hospitals. We have chosen to target 13 banks with affiliated research centers. By targeting these banks first, we will actually be able to generate revenue prior to FDA approval because selling units for research use only does not require FDA approval. We'll also be able to gather performance data as well as build strong customer relationships with these finite number of customers and leverage that along with our first mover advantage and our Johns Hopkins network to gain significant market share in the US and internationally as well. Now, moving forward, we've delineated out over the next 4 quarters our engineering milestones so that by this time next year, we expect to have a complete design freeze, have our regulatory manufacturing strategy flushed out, a full utility patent filed, as well as several academic papers published. Now, moving forward, we're evaluating several exit strategies that revolve around positioning ourselves for either acquisition or partnership by one of the 3 major players in this field, including cord blood bank, kit manufacturers, and blood processing companies. Now, as our technology develops, we'll continually reevaluate our strategies. Now, we've been to a variety of different business plan competitions, competing some against best in the world, and we've done extremely well. And the most important thing about this was that we were actually able to get in contact with several interested parties that we hope moving forward will help us make our venture a success. Now, as for our team, we have Dr. Edith Gerwich, who actually identified this need over the summer and gave it to our team and has helped us develop it over the past year. Now, as for the future of the graduate students on the team, Chris and Matt will actually be continuing TheraCord full-time. Sean will be working as a JPIGO intern and working on TheraCord part-time. And James and I will actually be taking jobs with medical device companies on the West Coast. So we'd like to thank everybody who has helped us get to where we are today, especially the CBIT staff and our advisory team who has given us such great support and guided us through all the milestones we've had to reach over the past year. We'd especially like to thank the Hopkins Labor and Delivery who has let us camp out while we try to catch placentas in order to test them, as well as Carolina's Cord Blood Bank. And we'd especially like to thank our wonderful clinical mentor, Dr. Edith Gerwich. We would not be here today if it wasn't for her guidance on this project. So in conclusion, there is a high unmet need for an efficient method to collect umbilical cord blood stem cells. With this CBX system, we anticipate to recover 2 to 5 times more stem cells than the current collection methods, thus expanding the market to adult therapies and enabling the growth of the regenerative therapy market to help treat over 300 million people worldwide. As Dr. Kurtzberg said, the director of Carolina's Cord Blood Bank, we simply need more cord blood. We are TheraCord, solving collection and saving lives. Thank you, and I'll open up for questions.